right, guys, so we're here with section 10.6. So as you can see, I already have my theorems already written out. Feel free to pause me so that you can write them and stay up to date with this theorem. Okay, so jumping right in with theorem 10.12, this one says if two secants or two chords intersect in the interior of the circle. So I'm going to pause there because there's a very key word, all right, in that first part. So it says if two secants or chords intersect in the interior. Interior is the key word there of a circle. Then the measure of an angle formed is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. Wow, there's a lot of stuff there. All right, so one more time, let's go ahead and reread through this. So if two secants or chords intersect in the interior, again, interior of the circle, then the measure of an angle formed is 1/2 the sum of the angles of the arcs intercepted by the angle and its vertical angle. Okay. So here's what I want to make sure that we understand, all right, before we get started, is that the intersection of these two chords or two secants, all right, are not in the center of the circle. So what we're looking at today are not central angles, all right? That's very important for us to recognize. So if I look at example 1 here, okay, what I have here is the intersection of these two chords. And I'm going to tell you that this point right here is not the center, all right? So that's not the center of the circle. But what I want you to look at is this angle 1 right here. So if I look at angle 1 and I look at the arcs, all right, that are intercepted by that angle, that arc would be arc BC. And then if I look at its vertical angle, which is angle 3, that arc is AD. So what this theorem is saying is that if I wanted to find, I'm going to write like a formula for this. If I wanted to find the measure of angle 1, then that angle is equal to 1/2 the sum of the two intercepted arcs. So that angle 1 is equal to 1/2 the measure of arc BC plus the measure of the arc intercepted by its vertical angle, which is AD. So that would be to find angle 1. And obviously if we can find angle 1, then we could find angle 3 because they're vertical. All right, but then now let's take a look at angle 2 and angle 4. And if we look at angle 2, the arc that's intercepted by angle 2 is this arc CD. And then vertical to 2 is angle 4, and that arc is AB. So if I would write a similar formula to find the measure of angle 2, this would be equal to 1/2 the sum of those two arcs. So it'd be 1/2 of the measure of arc CD plus the measure of arc AB. So let's go ahead and apply this. All right, so if we look at example 2, it says to find x, okay? So looking here, all right, I have these two chords of TS and RU. All right, the intersection point is not at the center. Again, very important, okay? So what this theorem is saying is that if we look at the arc intercepted by that X, that's going to be arc TU. And if you go vertical to that X, that arc is RS. So to find X, that is going to be equal to 1/2 the sum of the measures of those two arcs. So the measure of arc TU is 130 plus the measure of arc RS, which is 84. And so now I'm going to simplify that. So I'm going to add 130 and 84 together. And I'm going to get 214. So x is equal to 1/2 times 214. And now cutting 214 in half, I'm going to have x is equal to 107 degrees. All right, let's try the example right beside it. So the example right beside it, all right, is a little bit different, slightly different, okay? So if you notice here, my x is right here, okay? But if I look at the arcs that are intercepted by those two, I don't have those arc measures, right? But what I do have is this arc of 75 degrees and this arc of 143 degrees. So here's my plan, is I'm going to take those two arc measures and I'm going to find this angle that's right beside x. And then I'm going to take that angle and subtract it from 180 to find the measure of x, because those two are supplementary. Okay, so let's go ahead and call this y. So let's find y first. So using that same theorem, I'm going to have y is equal to 1/2 the sum of those two intercepted arcs. So I'm going to add 75 and 143 together. So adding those two together, I'm going to do 75 plus 143, which is 218. And then I'm going to cut it in half. So then divide it by 2, which means that y is equal to 109. But I'm not looking for y, I'm looking for x, right? So what I'm going to do now is I'm going to take that 109 and I'm going to subtract it from 180. So I'm going to do 180 minus 109, which means that my x is 71 degrees. So our last example is, again, a little bit different, all right, because if we look at x this time, all right, this time x is going to represent an arc measure, and I'm given the angle measure, correct? So I'm going to have to work backwards in order to find that missing arc. So using that formula, this time I know my angle. So my angle is 110 degrees is equal to 1/2, and x is one of the arcs I'm trying to find, plus the other intercepted arc, which is 97. So solving backwards, I'm going to multiply both sides by 2 to get rid of that 1/2. So do 110 times 2, which is 220, equals x plus 97. And now I'm going to subtract out that 97, and I'm going to get 123. So I have x is equal to 123 degrees. So I'm going to pause here and then come back for theorem 10.13.